All right, welcome back, everybody, to our monthly program of Hack Central. Per the usual, this is our Hack Central program where we go into more advanced computer science topics, usually dealing with machine learning, or if something cool has caught my eye and something we want to talk about. We've done a lot of machine learning algorithms we've talked about, ranging from linear regression, talking about classification. We've talked about some cool Python libraries and the stuff we can do with that. And as always, glad to see you guys are here with us. If not, if you're watching the recorded version, that is great as well. But without any further ado, let's get into it. And today's topic, which our Hack Central program will be entailing for this month of November, is going to be dealing with face detection. This is going to be a separate area of machine learning, which we'll be diving into. If you recall, over the past 4.5, 5 months, we've talked a bunch about various machine learning algorithms and how they can allow us to make predictions and classifications. We started off by talking about simple linear regression. We talked about how we could use a line of best fit and that idea of a y equals mx plus b equation and input data and sort of see how correlations are able to be made. Then we worked our way up, getting a bit more progressive, not only the math behind the algorithms, but also the names. They got a bit more funky, to say the least, with the k nearest neighbor. We talked about support vector machines, and we talked about how and in what cases they are useful. And although we talked about them, we did a lot of cool activities like with the console. We never really got to see if like an actual project in a sense, right? Well, today we're going to be putting some of those skills together and seeing how using some of those algorithms and something extra, which we will be going over today, we can actually detect images, detect faces in images. And that's going to be the focus for today. So without any further ado, let's get towards that. As always, guys, if you do not already know who I am, my name is Rayaan Siddiqi. I'm a senior at James B. Cohen High School. Love to program in multiple apps for the App Store, dozen different websites, and really like doing stuff for the internet, such as writing articles, making my own YouTube videos on the side. And as always, if you want to learn more about me, you can check me out at my website at rayaansiddiqui.com. And not in a couple of days, actually, hopefully in the next couple of weeks, you guys will be seeing another member. You can probably see them in the panelist lobby. She will be joining me in a hopefully in the next couple of weeks, and she'll be in the team as well. I think that you can see her right there. So we'll be collaborating and making this program even better. But that's just a quick sneak preview for the upcoming weeks. And as always, guys, if you are interested in what we're going to be talking about today, if any of this interests you, I would highly recommend that you check out our other programs from our Tech Bytes Intro to Programming and our web development course. Remember, on every other Monday, it's a bi-weekly program. From 3:30 to 4:30, we make projects. We discuss fundamental concepts in the language of Python. And then every Wednesday from 3:30 to 4:30, we talk about the language of JavaScript. Right now we're making a Hangman computer-powered game, and that's been a lot of fun for the past couple of weeks. And as always, everything is available on our YouTube channel in the Schomburg Library. And then we got a little bit of our fun program, which is every other Friday, bi-weekly program of teen trivia, where we kick off our weekend with a little bit of trivia, usually dealing with current events going on. Last Friday was dealing with the election. And yeah, I would highly recommend if you want to come out, have more fun with us, enlist in these through the Schomburg Library's website. But now let's get towards today's topic, that being face detection and seeing how we can perform face detection in images, draw that rectangle around somebody's face using the language which we have been extensively studying for the past couple of months of Python. So speaking of Python, guys, we are going to be using the language of Python once again. And by now, you should probably expect me always saying Python, Python, Python with machine learning. And hopefully the idea that Python is an amazing language for implementing machine learning algorithms is stuck in your brain. We've talked about a bunch of algorithms, and we always do them in Python. And the reason for that is because there are a bunch of awesome libraries which we can use in order to manipulate our data and essentially make predictions and make those classifications. We've used NumPy, we used Keras, we used TensorFlow a lot, and we used Matplotlib, not as much in the past couple of Hack Central editions, but for sure in the beginning when we were trying to draw out our data, visualize it, Matplotlib was a pretty good library to show all that. And today we are going to be talking about a new library, one which we have not really covered in the past, if I believe correctly, that being one called OpenCV. Now, this library is going to help us a lot in being able to essentially draw a rectangle around somebody's face. And the way that's going to be possible is we're going to be learning in the next couple of slides. but this is a library which is going to be our main focus for today. All right, so let's get started. All right, so the way in which we are able to make detect a person's face on image with Python is using this idea of a hair cascade. Now, the spelling not only seems a bit weird, but hair cascade, what does that even mean? Well, how about we first of all talk about what is face detection simply? Well, it's what it sounds like, right? Face detection is when we're able to, if you put it in an everyday context, everybody has a phone, right? Say you have an iPhone, a Samsung. You usually, if you have a updated version of a Samsung and iPhone, you probably have the feature where you can just hold up your phone to your face and your phone unlocks. About a couple years ago, the only way to go into your phone without having to manually input a password was through a touch ID. However, in the past couple of years, there is something like Apple calls it Face ID. You just put your phone up and automatically it lets you in. Well, the way that is possible is through the general idea of machine learning. And the way those face detections are able to be made is using this thing called a hair cascade, which we'll be talking about in a little bit later. And through using these hair cascades, we are able to make predictions which allow us to identify certain human features in images. Now, when we're talking about hair face detection, we're obviously talking about detecting somebody's face. However, using this hair cascades algorithm, we're also able to check for eyes. We can check, draw a box around somebody's mouth, their nose, ears, whatever you want to do. There's a bunch of humanly features which you can detect. And the way those predictions are able to be made with is through using an algorithm we actually talked about last time. Sort of comes nice into play, right? We talked about this algorithm last time, that being the support vector machine algorithm. That whole idea of creating hyperplanes, dividing our data up, seeing where it falls, and then classifying it. And one of the ways how face detection is able to be made is actually through that support vector machine algorithm we discussed last time. So let's get back to this idea of what is this hair cascade. Well, the main idea is that it's an object detection algorithm. Now that should make sense. Object detection algorithm. We've talked about slightly objects, right? Detection, meaning we're looking for something, trying to identify a certain element in maybe our image. And algorithm, we all know what that means. It's a piece of code which we have written. So putting all that together, we have an object detection algorithm which allows us to extract and see and identify certain things in, say, an image in this case, right? And now this algorithm is a bit different. So we talked about how we can detect faces with, at the bottom, we got a little note right there saying with the support vector machine algorithm. But this hair cascade is a bit similar, but consists of the same concept. The end goal, guys, is for us to be able to identify a certain feature. Now, whether we do that with our support vector machine algorithm or whether we do that with something called the hair cascade is totally up to us. And today, we're going to be looking at how to use a hair cascade, the object detection algorithm, in order to identify a face in some preloaded images I have. So essentially, to boil this down, the way this algorithm is trained is through having positive and negative images. Now, we've talked a lot about what makes for good training data, how the training data should be different than the testing data. You shouldn't be able to see the answers to a test before a test, right? That wouldn't really make sense. Defeats the purpose of the test. Well, similarly, is something similar to this hair cascade algorithm and the way we train the model. You see, we have positive images and then negative images. A positive image is one containing something which we want to classify. So if we go back to the example of, say, we're doing any face, right? We want to classify a face. So if we have an image, say, like right now, I'm a virtual background. We have all of this noise, everything around me. That is pretty much useless to our model. Not only are we using more computer memory, but we're just wasting time for our model to be trained on something which is not even necessary. Instead, what would be more ideal is that if we have like a cropped out photo of just my face, because that is the only thing which matters in this scenario. If we were trying to identify something like, say, like that lamp, then that would be a different situation. But speaking of that image which we don't want, that translates nicely into something called a negative image. And if you guessed it, the negative image is an image of everything else. So essentially, everything which doesn't contain the thing we want to identify, that will be classified as a negative image. So going back to that example, if we take a screenshot of this whole image of mine on Zoom right now, that would be classified as a negative image. However, if we crop and trim that down to just my face, maybe my chin as well, that would be classified as a positive image. And through training our model with such, we are able to use some code in order to detect and draw some boundaries around any feature we are looking for. And in today's case, that is going to be the face, which we will see in a couple of minutes. All right. So we've talked about how the algorithm behind some face detection works at the basic level. But remember, if you go back, we talked about this library we'll be using today called OpenCV. Now, if you remember correctly, I mentioned that this library makes it super easy for us to make those detections. And mainly because that library has a bunch of preloaded models which are trained in order to detect faces. So it makes it super easy for us to not have to create our own hair cascade model, train our model through that algorithm, and waste that time, right? So this OpenCV library makes that super nice. And some notes on this model, which I want to touch on, is that it only works with grayscale images. So I will show in a couple of moments is that say we have an image filled with color, right? I'm outside, I take a picture, and I want to classify where my face is at. Well, sure, we can input that image when we are trying to make the detection of our face. However, when we are going to use this OpenCV library, our goal is going to be to make sure that we convert that image of color with red, green, blue with RGB colors into a grayscale image. And the main purpose of that is so that the OpenCV, through OpenCV, that's the only way it is able to detect faces and other features of our body, our face, nose, like we mentioned before. And also, it's pretty simple. It's not like I have to manually go ahead and turn every pixel into a grayscale picture. There's actually one line of code, which I'll show in a little bit, which takes care of that for us. And some other quick notes I got to the right. The main function which we will be utilizing today is one called detect multi-scale. Now, this is the function which is going to be performing all of the classifying, and it takes three important parameters. Now, remember, parameters are values which we can pass in to functions, to algorithms, which abstract and make our code easier. We've used them a bunch in our Python and JavaScript course as well. And today, three important parameters which our OpenCV algorithm will be taking is going to be firstly, the input image. Now that image is going to be one which I already have, so I'm just going to essentially write wherever it is located in my directory. Then we're going to have something called a scale factor, and that scale factor is going to dictate how much we are going to reduce our image. And that the scale factor and the third bullet point right there, the minimum neighbors. The minimum neighbors is used to essentially, if we have a higher value for our minimum neighbors, the better quality faces detected. So what that means is that if you go back and think about to some of our algorithms like the k nearest neighbor, we've talked about how there are certain points which we look at in order to make an establishment of where to classify a certain piece of data. Well, this minimum neighbors is something which I do not want you to get confused with. Essentially, this minimum neighbors and the scale factor, both of these are numbers which we keep tweaking and changing until an accurate prediction is made. Now, although that might sound a bit silly, it's true. There are two parameters which you want to keep on perfecting, going up and down, and until you can find the perfect combination, that's when you know you made the right detection. It's sort of similar to when we talk about, say, any type of algorithm like a linear regression or k-means. We're trying to separate how much data is going to be our training data and how much is going to be in our testing data set. And we keep on playing with the percentages until we get the highest amount of accuracy. So sort of a similar concept in the sense that we're going to keep on tweaking these numbers until we can get an accurate prediction. And it's nothing much more than that. All right, and per the usual, guys, since we do like talking about some math with all of our algorithms, whether it be some algebra, some calculus last time as well, but this time it's one of not my most favorite or strongest math classes, that being geometry. Now, if you hate it or love it, geometry is always going to be something which is going to be a part of not only your lives in everyday life, but also a major part in computer science, and especially in today's context, right? We're talking about making face detections, drawing a boundary around someone's face or mouth, whatever you want to classify. So we're thinking about all of these shapes. Geometry has to be somehow involved, right? Well, you're right. And the main idea, which I want to get across without going too deep, is that we're going to be using geometry in order to relate how our camera sees somebody's face to a regular X, Y, and Z coordinate system. And the way that is going to be possible is that we usually have some matrices which are relating the placement of, like, say, our face, and essentially using some matrices multiplication, some translations, and some reflections, we are able to make a pretty accurate prediction as to where the 4 points around someone's face is. And lastly, using some code, we're able to draw a boundary around that region. So without any further ado, how about we get towards talking about our scenario and what we're going to be doing today. So we've talked a bunch about the nitty gritty, the bolts and details about how this algorithm works and how we're going to be using this library called OpenCV in order to make something pretty cool. And our scenario for today is what we discussed at the beginning, that being that we're going to use a previously trained classifier with our hair cascade model in order to detect faces on some input images. So without any further ado, how about we open our Python environment and check out how this works in some real-time action? How about that, right? So I'm going to open up my environment real quick. Give me one quick moment. All right, there you go. You should be able to see my PyCharm app open with a little script I got going on. And now, at first glance, you're probably, how about we just take a look at what happens, and then we'll get down and talk about some of the cool code. So if I hit run, I already got an image. If I'll pull it up right now, it's a basic image of me, if you didn't recognize me already, right? What it's going to do is that it is going to draw a box around my face. So how about we see if that works firstly? So I'll just run that real quick. And I don't believe you can see that, so let me share my screen again. So there we go. You can probably see my terminal output right there. And you can probably see a pretty good box, right? Drawn around my face. It's pretty accurate. Actually going to exactly my chin level. We got a little bit of inaccurate prediction, right? It looks like my color of the suit is being detected as a face. Now that could be because the model we're using is inaccurate, or it could just very well be the picture, or it could be the parameters. So a lot of possibilities as where and how we can improve this. And those parameters are going to be dealing with the detect multifunction algorithm we talked about earlier. So that's what this little piece of code will do. But how about we talk about how that is able to be done? That is always the cooler part, right? So how about we share our screen again? All right, there we go. All right, so here is our OpenCV library, which we're using today. It seems a bit weird, CV2, that's basically the name of OpenCV. That is how we install it. Here is where we are preloading that hair cascade model, which I talked about at the beginning. Now, this model, which I'm using, is specifically made in order to detect the front face of somebody. However, if you go on the internet, you can for sure find a XML file with a model which can detect eyes, eyebrows, teeth, mouth, ears, all that good stuff. Here is where I am loading in the image. So this is my Rayaan. It's called Rayaan photo. I am reading that image in, right? That image I read. Pretty simple. And here is the pretty cool line of code. Essentially, remember, I was talking about how the image which we are passing in into our function has to be in a grayscale setting. Well, we got a one line of code which can do all of that. Pretty cool. Essentially, we got cbt.color, which stands for convert to color, and we're converting it to a grayscale setting. Now, here's another cool part. In one line of code, we're able to detect and see where a face is. So remember, this first parameter is representing the input image in grayscale. The second parameter is representing how we are scaling our image. And this last parameter is checking for, essentially, it's a number which we keep on tweaking. And essentially, that number, remember, does mean how the quality of our images. So let's see, if I make this, let's see what happens with 3. So if I change that number to 3, do we still see? Okay, yeah. So I can still see it, but if I reshare my screen, that little box is still being drawn off to the left side. So it seems like that we still have some code to change up, but that is all right. Using this for loop, guys, we are able to draw a physical rectangle, that blue colored rectangle which shows up around my face. And then lastly, with these last two lines of code, we're able to actually show that image and the final product with a square around my face, the region which we are detecting. So if you're like me, you're probably thinking that, hey, we're able to do all that cool stuff we talked about involving loading a model up, having a trained model at our hands so quickly, and being able to not only detect the face but draw a boundary around it in only what seems like 20 lines of code, even less if I get rid of the comments and the blank spaces. And it goes back to the idea that, guys, the language of Python makes us super simple and makes our lives much, much easier when performing these tasks. When we talked about some other algorithms like the KNN, so SVMs, we talked about k-means, all of them are able to be done in a relatively short amount of code, usually between less than 50, if not less than 100 lines of code. And it goes to show us once again the cool reach of Python and the awesome stuff we can do with it. All right, guys. So that wraps up our Hack Central for this November 9th date. As always, guys, if you guys have any questions, I am more than I'd love to answer them in the chat. You can always communicate with me through the Google Classroom. I know some of you do like to do that. You guys just post on the Google Classroom, which is totally acceptable. Or you can just privately chat me. But in any case, hopefully you guys had a cool time today. Some of the cooler things we have examined with our Hack Central program. And I hope that you guys will be coming back. If not, I will see you in this Wednesday's web development course. But yeah, I'll catch you guys in the next one then. Take care, guys. See ya.